So we've been talking about what these intermolecular forces do. What are these intermolecular forces? So we mentioned before, these are forces of attraction between molecules, and they are electrostatic in nature, which means they are attractions between positive and negative charges. The strength of them is important. It affects the state of the substance at a given temperature. It affects the boiling point and melting point. It affects the viscosity and the surface tension and all kinds of good stuff. So the first one we're going to talk about is called a dispersion force. These forces go by other names as well. They're sometimes called London forces, or London dispersion forces, or van der Waals forces. And they're also called induced dipoles, which is my preferred name for them, but I will try to remember that your book does not use that. So these are also induced dipole forces, which is a more descriptive name, and that's why I like it. It's really messy. So this dispersion force is present in all molecules and in all atoms. And these are caused by fluctuations in the distribution of the electrons in the molecule or the atom. Since all atoms and molecules have electrons, all molecules and atoms have dispersion forces. So what can happen is that at any given instant, the electrons in an atom, we're going to talk about helium just because it's simple, has 2 electrons. So here we've got 2 electrons, and they're kind of spread out, and here they're kind of spread out, and here they both happen to be on one side. Okay, that can happen. They're just kind of random. Like, my children, when all 6 of them are home, they're generally kind of spread out, but every once in a while, and I have a picture to prove it, they were all 6 of them on the couch. Nobody told them to go there. They're just like all sitting there. How weird is that? They didn't last long, just long enough to get a picture. But electrons can do that. Usually they're kind of spread about, but occasionally they'll all be on one side and make the atom lopsided. This causes a temporary dipole or an instantaneous dipole in this atom. So this side where the electrons just happen to be for a second, actually like a very tiny fraction of a second, partially negative. This side partially positive. Well, what happens is, so here we have our lopsided atom, partial negative, partial positive. This partial positive charge on that side of the atom, if it is near another atom, attracts the electrons of the neighboring atom and causes that one to be imbalanced also. And now we have plus minus, and there's a little bit of attraction there. It's like these electron negative side, I like your positive side over here. And then this one's lopsided, and it induces a dipole in the neighboring molecule. And then these guys decide, oh, what are we doing on the same side of the house? And they spread out again, and then it all goes away. So these instantaneous dipoles cause forces of attraction between neighboring atoms. And they come and they go, and they come and they go, and they're very, very weak. But because they come and go so frequently, it does add up to be significant. So the dispersion force happens as neighboring atoms are attracting each other. The instantaneous dipole induces a dipole in the neighboring atom, and then there's this force of attraction. And we'll finish talking about this next week.